Okay, this is 5.3. We're learning about common factors. So the first example here, we have 6, and we want to know what the factors are. So the factors for 6 are 2 and 3. 6 and 1 are also factors, but we are looking for the prime factors, so the other numbers that are undivisible other than 1 and themselves, so that's 2 and 3. Polynomials also have factors, so here is our standard form quadratic, x squared plus 4x plus 3. Factors of this are x plus 3 and x plus 1. Now, you don't know yet how to go from here to here, okay? But what you can see is if you multiply this out, so if I were to do x plus 3 and x plus 1, using FOIL, right, our first terms, and then our outside terms, and our inside and our last terms, we would get x squared plus x plus 3x, so it's plus 4x, and then plus 3. Okay, so you can see that these are in fact factors of this term if you were to multiply them out here. Okay, so we're going to figure out how we go from here to here throughout the course of this chapter. So factoring a polynomial means writing it as a product. So factoring is the opposite of expanding. So expanding, we're going this way, and factoring, we're going back. Okay, so when a factor is contained in every term of an algebraic expression, it's called a common factor. So we can determine common factors mainly by inspection. So if we were to write this factored form out, so here's our polynomial 2a squared b. If I were to just write this out in its factored form, look like this, and then we can write 2 times 3 times b times b. Right? Now we can see what our greatest common factor is. We can see the 2's are common, and we can see that there's a b that's common. And that's about it, right? So our greatest common factor would be 2b. Would it get squared? No, because this 2 is with this term, this 2 is with this term, so they don't go together, they don't multiply. So the greatest common factor here, if I were to write this out, we could say 2 times 5 times x times x times x. 15 would be 3 times 5 times x times x times y times y. Now we could get our greatest common factors. We can see these two are the same, these are the same, and that's it, right? So our greatest common factor would be 5x, which is equal to 5x squared. Any questions so far? Next one, 3xy, we can't do anything with that, so I'll just rewrite it out like this. 6yz we can rewrite as 2 times 3 times y times z. And finally 9 is 3 times 3 times 3 times x times z. So here we can see the only thing that's in common between all of them is a 3. So our greatest common factor is just 3. Alright. I'm assuming this is supposed to be x cubed. So let's write it like that. 8 is 2 times 4. Or actually it's 2 times 2 times 2. I guess we could rewrite it like that. And 10 is 2 times 5 times x times y times y. So here we can see y is not in common. The only thing that's common is just x, yeah. Alright. So we're going to factor these completely. Who wants to try the first one? Anybody? Jafet, you want to give this a shot? Check by expanding. So factor this completely. Let's go the quicker way here. We're just going to go Greatest common factor, what would the number be, Jafet?
5.
5. And is there any variables that are in common?
Y.
Okay, good, y. Okay, so that's the greatest common factor. Now you put brackets. What's left with this term? If you divide this term by this term, what do you get?
Just x.
X plus
2y.
2y. Yep. And now we can check it by expanding. We get 5xy and then plus 10y squared. Right? If you just multiply them out. So this is the same as this. Next one. Rudy, you want to give this a try? What's the greatest common factor? 3, good. Is there any variables that are in common? What is it? Okay. X, and then what are you left with at the first term? You're going to divide each term by 3x. So 6x cubed divided by 3x is 2x. 3 divided by 1, right? 3 minus 1? Yeah, squared. Okay. Minus x. Good. And then plus here 12x divided by 3x. Yeah. Any questions here? You can check it and multiply it out. We get 6x cubed minus 3x squared plus 12x. Yeah, Alan. This stuff in brackets, I'm dividing each term by the greatest common factor. So 6x cubed divided by 3x is 2x squared. Okay? The next term, 3x squared divided by 3x is x, and it's negative because of this negative sign. Alright? Alright, to factor a polynomial, remove the greatest common factor as the first factor. That's what we're doing here. Okay, and then divide each term by the greatest common factor to obtain the second factor. That's what we're doing here. Any questions? Alright. Okay, polynomial is completely factored when no more variable factors can be removed and no more integer factors other than 1 or negative 1 can be removed. Okay, so RC, you want to try this one? What's common in the coefficients or the numbers? Yeah, the only thing common is AB. You're right. There's no numbers common, so AB is the only thing because this has AB, this has AB, this has AB. So now 3ABX divided by AB is what? 3x, yeah. Now, minus ABY divided by AB. Yeah, negative y, good. And then the last one, minus, because the minus sign, 2z, right? Now, if you want to check, you can multiply it out. You should get that. Okay, Alan, try this one. What's the biggest number that's common? 8, good. Okay, and the biggest variables that are common? Sorry? Yeah, a and x. Good, that's this one, yep. Okay, so now 24a squared x cubed divided by 8ax is what?
3ax squared.
Yep. Next. Yep. Perfect. Very good. Common factor is not necessarily a monomial factor completely. So in this case, when we say it's not a monomial, remember, is just one term. Polynomials, these are all one term. In this case, we're going to get a common factor that's not just one term. It can be more than one term. Josiah, what is common between this term and this term? Sorry? Yeah, the y, not just the y though, the y, yeah, plus y plus what?
Y plus 8.
Right, that y plus 3 term is common to both terms. So now, Josiah, if you divide both terms by y plus 3, what are you left with? This divided by y plus 3. What do you get? These are going to cancel, right?
Yeah.
So what do you get?
0.
No?
Y. Oh wait. 2x.
Right, 2x. And then, when you divide this by y plus 3,
You get 5w.
yeah, 5 plus 5w. Okay? Next one. Jaden. What's common? Yep. T minus 4, yep. And now, when I divide this by t minus 4, what am I left with? Yep. Now this one divided by t minus 4. This divided by t minus 4. So they're going to cancel out. What are you going to get? Sorry? Not 0. When something you divide something by itself, what do you get? 1, right. Is it going to be plus 1 or minus 1? No, because then there's negative sign right here, right? Minus 1.
Kind of confused. For A, why do you leave y plus 3 in brackets?
Because it's the whole binomial. This whole binomial is common. So it has to be in brackets because it's the whole term. Can't just separate the y and the 3. They're together.
So since the term at the top is together in brackets,
Yeah.
carry that on to the bottom.
Exactly. Yeah. Maxis, try this one. What's common?
Have like the coefficients of the numbers.
Yeah, or anything. What's common between these?
1.
Okay. This one's tricky, right? Because we have our signs reversed here. Do you notice this? Okay. Anybody know what we can do here? How can we fix this? Actually, have to do like a double factor here. So watch this. We're gonna fix this term here, 5 minus v. The way we're going to fix it is we're actually going to factor out a negative 1 here. That will change this 5 to negative, from positive to negative, and this v from negative to positive. So what we end up getting is this 5 becomes negative 5, and this v becomes positive v. Okay? We know that, right? Because if we multiply negative 1 times negative 5, we get positive 5. Negative 1 times positive v, we get negative v. So I've taken the negative 1 out of this term and put it on the outside. You see how I did that? Yep.
Where did negative 1 come from?
I divided both terms by negative 1 and brought it out to the outside. I factored it out. I've chosen to do that. Basically, I'm changing the signs. I'm taking the negative sign out.
Okay. So you just switch.
So now if I rewrite this, plus what I'm actually going to get is this negative 1 turns this positive 3c into negative 3c. And then this I can rewrite with the v first minus 5. Does everyone understand that? How I got to here? Sort of? Yeah?
How did you get negative 3c?
Because of this negative 1 times positive 3 becomes negative 3.
How did you get negative 1?
Negative 1, I've divided out of this term. I've taken the negative 1. It's out of this term. Do you see how this is the same as negative 1 times this? See, if I multiply negative 1 times negative 5, I get positive 5. And negative 1 times positive v, I get negative v. So I've taken the negative value out of this binomial. Pretty confusing. It's hard to explain, but yeah, I'm taking that negative sign out. Now that I have it rearranged, how can you finish this, Maxis? What's common between these two terms? Yeah, these two terms here, this term and this term, what's common? No, there's a binomial that's common, right? Right here. You see it? I'm talking about the v minus 5. See how it's common in both terms? So that's the value I want to factor out, right? V minus 5. So what am I left with if I divide both terms? Yeah. That's the answer. Yeah. The point of factoring the negative 1 out is so that these two terms, this and this, were the same. See how they're not the same at the beginning? It's negative 5 and plus v. They have opposite signs. You see that? So I can't factor it out until they're identical. That's not going to happen that often. But if you see something like that where they look very similar but they're not the same and they're off by one negative sign, you can factor out the negative 1. Sorry? No, they're not. Even if I reverse this, right, it would have been v minus 5. That's not the same. Oh wait, you're right. They were just in the wrong order. Does that change anything? Let me see here. Yeah, sorry, KG, you're right. These were just flipped. Why did I have to divide by negative 1? Plus 5. Yeah, you're right. I think you're going to end up with the exact same answer, but I think I made that more complicated than I needed to. Let's do that again. KG's right. They were just out of order. No, they're not. They're not out of order. They were only out of order here because I'd already taken the negative sign out. But here, do you see at the beginning, KG, how they have different signs? Do you see?
Wait, sir, they have different signs. I'm assuming they're common.
Right. They're not common. Do you see here how this is positive v and this is negative v? Do you see that? You have to make them the same. Positive 5 and negative 5. So the only reason they were the same in different orders is because I had factored out the negative 1. So everything I did initially was correct. Have to take out that negative 1 in order to make that a negative 5. And now once you have it as negative 5, you can then reverse the order and make it the same, right? Sorry?
Why is 2D right there at the start? That's what you're dividing everything by?
No. 2D is just with the first term. That's why it's always there. See, it's with the first term.
Why don't you put the first thing that's like the common?
Yeah, but I haven't grabbed the common value yet. I was just rearranging this so that they were common. Now I'm grabbing the common term. Here. Okay? If a polynomial has more than 3 terms, you may be able to factor it by grouping. This is the only possible if the grouping of terms allows you to divide out the same common factor from each group. Alright, so let's see what we're talking about here. So if I factor this out, I'm going to get 3a minus 3. And if I factor this one, I'm going to get 4a minus 3. Now we can see that the greatest common factor is a minus 3. See what I did there? So I'm factoring both of these. Then I noticed that a minus 3 is the same. That's the greatest common factor. Next, I'm going to factor out x plus 1. Here I'm going to factor out 2x, and I'm going to get x plus 1. My greatest common factor is x plus 1. Actually, it's x plus 1. Any questions? All right, sample 4. Factor, check by expanding. Okay, so greatest common factor here. So here we have 4. We want to factor the first two terms to get x minus 1. And then we have that second term, x minus 1. So now we have two factors that are common. So we can take out x minus 1, and we're left with x squared plus 1. Next, we have two terms here that have a common variable of c, two terms here that have a common variable of d. So I'm going to factor that out, a plus b minus d, a plus b. Now this is tricky here because there's two negatives. I'm factoring out negative d. So now when I divide both of these terms by negative d, I get positive a and positive b. Gotta be careful with that. So a plus b is common here, and we're left with c minus d. Any questions with either of those two? Just tricky because of that negative sign. Okay, next one. We're going to factor out here what's common. Here we can see x's are common here, and here nothing is common. I don't think we can factor this. I don't see anything common. If I do x minus 6, not going to help me here. Plus, I have nothing common between the 9 and the 4. What if I were to rearrange this? No, I don't think we can factor this at all. Nothing is common. Nope. No common factors. Let's try this one. Okay, here I can see the y's are common and the x's are common. So let's rewrite this. Bx plus 3x plus 3y plus by. So all I did was move the 3x in front of the 3y, right? So that allows us to grab the common term here, which is x, and we get b plus 3. And now we have y, and we're left with 3 plus b. These two are the same because the signs are all positive. So we can factor that out. 3 plus. Let's rewrite one more step just to show it. Okay, last one. Here we can rearrange, put the 3 with the 9, I think makes more sense. And then I leave my negative 15x minus 5. We're going to say 3x is common. I'm left with 3x plus 1. Here, minus 5 is common, and you get 3x plus 1. Okay? Any questions there? Yeah.
I don't understand.
Which one?
How you got 3x plus 1?
Here?
Yeah.
So 9x squared divided by 3x. So 9 divided by 3 is 3, x squared divided by x is x, and 3x divided by 3x is 1. I'm dividing both of these terms by the greatest common factor between them, which is 3x. Do you see that?
How is it 3x?
Because it's the biggest number that goes into both is 3, and x goes into both, 3x. See? Any other questions? Yep.
You're putting 5.3 and 5.4 and 1.
I'm going to stop the video and start the next one. Yeah.
Where did the negative 15 go?
Where did this come from?
Where did negative 5?
Negative 5?
No, yeah. Where did the negative 15x go?
Negative 15x was divided by, so what's common between these two terms is negative 5. Goes into both. So negative 15x divided by negative 5 is 3x.
Are they not like intergrouped because of their sign?
What do you mean? What?
Then where did the negative 5 come from?
This negative 5 came here. Because I factored out the 3x plus 1 comes here. And then what's left? 3x minus 5. This one? Negative 5 divided by negative 5 is plus 1.
Oh.
Okay? Any other questions? You guys, really, I know seems like it seems like a lot, maybe confusing. It's just like anything else with math. You just need practice. You have to do the homework over and over. All right? The homework is here. This is at the bottom. If you don't do the homework, this stuff will not stick. It will always be confusing. If you do the homework and you check the answers, you're going to get it. It's just going to take some time. All right, I'm going to stop it here.